Greetings, I am Krishna Teja Murikipudi of BTech 4th year Electronics and Communications Department of Puducherry Technological University. I want to share my experience at Microprocessor and Embedded Systems Internship project of EMERTXE. I have done this project in the year of 2023. Overview. This is a 1-month long internship that focuses mainly on industrial exposure, real-time applications, and it focuses on bridging the gap between industry and academia. Any individual from any background can take up this internship because they teach everything from the basics and they make you develop real world skills. Some of the key takeaways are microprocessor architecture and programming, embedded system design and development, industry standard tools and technologies that are totally open source and free. We work on real world embedded system projects here. We network with other talented students and professionals via discussion forums, and the main point that is not mentioned here, EMERTXE aims to eradicate a thing. We students, especially the people from the tier 2 and tier 3 institutions of India, we tend to pay to do an internship, which is not supposed to be like that. So EMERTXE aims to undo this. They provide internship to the rightful people free of cost. Goals of this internship: bridge to the industry. As I said earlier, they try to bridge the gap between industry and academia. Real-time projects, they make people industry ready. They teach us even resume building, versatility in embedded systems, overview of embedded systems, C programming, microprocessors, and also how is the career, what are the statistics, how is the career in microprocessors and embedded systems, how is the market going, what is the current trends. They teach everything in DISHA workshop. Project requirements, there are no prerequisites as such, and it is better if you have a little bit of knowledge of C programming and microprocessors beforehand. We need to have a laptop or PC, MPLab IDE, Excite cross compiler, PixSimLab simulator. All of these are basic requirements. There is no complexity involved. It is a versatile environment where we can develop anything from scratch. All these are open source tools, as I said earlier. This is the PIC16 F877A microcontroller. This is PIC Genius board. This is 16x4 display, fan. These are tactile keys. These are 7-segment displays. These are LEDs, array of LEDs, dip switches, everything is present here. This is the basic environment where we simulate our results. What are embedded system? Embedded system is a computer system that is designed to perform a specific task rather than general purpose task. Like for suppose, if we take a washing machine, we cannot accommodate a computer there. It will be both expensive and power consuming, and also the space. Yeah, but when you take a computer, it does all kinds of tasks. But when we talk about embedded systems, it is designed to do a specific set of tasks or a specific task. Embedded systems are generally found in consumer electronics, industrial control systems, medical devices, transportation systems, everywhere. Embedded systems are typically characterized by the following features. Yeah, as I said earlier, they are designed for a specific purpose and they may not be general purpose computers. They are constrained in the terms of size, weight, power consumption, and cost. Yeah, these become the deciding factors of what kind of board or what kind of microcontroller or microprocessor we use to develop a embedded system. the size, weight, power consumption and cost, the operational frequency, everything comes under this. They need to be reliable and robust. Yeah, what do you mean by reliable and robust? We might want to deal with real-time signals, and we might want to process real-time signals, so it should be reliable. Whatever is being displayed in front of your eyes should be the thing that's happening in the real environment. Sometimes it is very critical to monitor in real time. Let us say we are dealing with a pacemaker. If there is any very negligible error in pacemaker, that might kill a person. So they need to be reliable. They need to be robust. What do you mean by robust? Robust is being stable and being reliable in when a catastrophe or anomaly occurs. Let us say we are operating in a high temperature or a low temperature region, or we are operating in a high pressure region or a very low pressure region. We have to take in account all these factors to develop an embedded systems. We have to mention and decide the factors which affect the performance of the embedded system. They often need to be able to respond to real-time events. As I said earlier, we took the example of the pacemaker. They should be able to respond in real time. Any minor delay might cause major accidents. Peripherals used here. We use timers, 16x4 display, buzzer, matrix keyboard, fan, cooler. Excuse me. The design, as you can see, LCD display. All these are internal parts of big genius board. The buzzer, matrix keypad, fan, timer, LCD display. What we do here is we communicate with they communicate with each other via code. Sorry, via the processor. The processor gives commands to all these peripherals. So what we do in this particular project is we start with the LCD display. We display the power on screen, and then we take input from the matrix keypad, and based on the matrix keypad we choose a defined mode, and then going into that mode, based on that mode we give the required inputs, and then accordingly we turn on the fan, buzzer, timer, anything required. We will see the detailed explanation of how these things integrate together and work together in the demonstration video and in the further slides. Development process and tools. Yeah, development flow. First we have to know how the LCD works. We try to make the LCD work, and then we try to take inputs from the matrix keypad, and then we try to use the timer too. Actually we can use any timer, but here we use timer too for our convenience, and we should know how to use interrupts. We are developing step by step. We developed how to use LCD. We developed taking inputs from matrix keypad. We developed interrupts and ISR, interrupt service requests, and we developed how to use a fan and a buzzer. There are modes, 4 modes. We develop each one of them. What are the inputs to that mode, and what are the processes done by the mode. Inside that modes we might want to develop the functions for start, pause and stop, and also after everything is done we should give the control back to main menu. The device should not boot again, it should go to the main menu and display the 4 modes. The tools used in this are all open source, as I mentioned earlier. They are MPLAB X IDE, X8 Cross Compiler, PixSimLab. Implementation details. The project is a simple PIC16F877A microcontroller based microwave oven which has the following modes of operation: microwave mode, grill mode, convection mode, and start mode. Microwave mode and grill mode, I think need to give any explanation. Convection modes, it basically uh, preheats the oven so that you can use other modes, and start mode starts the oven with a 30-second timer. Let us see the demonstration video after this. Yeah, as you can see, we have come to the simulation environment, which is PICSIM lab. We have to select the PICGenius port, and also the, as you can see here, we can select the PICGenius port and PIC16 F877A microcontroller. We have to select the clock speed, which is 20 megahertz. We have done our calculations all based on the 20 megahertz clock speed, and also we have two options of LCD, 16x2 and 16x4, but for our project we are using 16x4 LCD display. So we have to ensure that LCD and sorry, cooler, that is fan, are turned on. Yeah, that's it. So now let us load our hex file. Load hex, as you can see. I create a hex file, distribution, default, protection, microprocessors. As you can see, in the powering on screen, you can see the percentage of how much it is loaded, how much percentage it is loaded. Then we come to the main menu, the microwave, the four modes: microwave mode, grill mode, convection mode, and start mode. Let us see each mode one by one. The microwave mode, the power is 900 watts. It displays the power of the given microwave oven. We arbitrarily fixed it as 900 watt because majority of the microwave ovens might have 900 watts. We can set time in minutes and seconds. The maximum time that can be accepted is 59 minutes and 59 seconds. Let us see. Let us enter a value. Let us say 23 minutes. Let us say I am entering a value greater than 60 or 59. Let us see what happens. I am entering 89. It is reset to 59 because 59 is the maximum permissible value of the seconds and minutes. As you can see, if I press the star button, it's getting cleared. Now I'll enter again. For simulation purpose, for demonstration purpose, let me not take too much long delay. So I'll set the time as 30 seconds. Yeah, 30 seconds. If I press hash, it will enter and the timer will start, and also the fan. As you can see, the fan has started. Yeah, and also the timer has started. It's 25 seconds. It's decreasing, decrementing. If I press start now, 30 seconds will get added. Yeah, as you can see, 30 seconds got added. If I press pause, the timer and also the fan are paused. If you want to resume the operation, you just have to press start again and it will start counting again. Yeah, it's resumed the operation counting. If you press 3, it will show time up, and also when the timer is has come to 0, it will also show time. Let me press stop. The time is up, the buzzer is on, and then we have returned back to my main menu. Let me go to grill. Grill is almost same as a let me see. Yeah, 30 seconds. As you can see, the timer is running. 28, 27. If I press a start or resume menu, it will increment by 30 seconds. Let me press the pause. Yeah, everything is working here. Yeah, let me stop this timeout. In convection mode, we are required to set the temperature. Whenever we set the temperature, the oven preheats itself and then goes and redirects into the set timer value. Okay, let us enter all these are in degree Celsius, mind it. The thing is, we have entered 780, but the maximum permissible value of temperature is 180. So when we press enter, the temperature changes to 180 and it feeds as 180. The maximum limit is 180. Yeah, so see the preheating time left is, yeah, I set the preheating time arbitrarily as 10 seconds. You can change it as per the requirement. Yeah, we are directed to set time menu. Here, as you can see, you can set time 396, but 59 is the maximum limit. Let us go back. Yeah, 00, 15 seconds. Let me press enter. Start 30 seconds increment. As you can see, when the seconds are incrementing, when it reaches 59, when it goes to 60, the minute will be incremented. As you can see, yeah, this is the process. And when you click pause, it will get paused. When you click start again, it will start it. When you click stop, it stops there. Time is up, the buzzer is on, and let me go to start mode. The start mode, it starts the microwave oven with prefixed 30 seconds. Let's see its operation, timer operation. Yeah, let me press the start and it will increment by 30 seconds. Yeah, as you can see, when I press pause, it gets paused, and also when I press start again, it's resumed. Let's stop this operation and let's see some border conditions. What happens if let us see the border condition. Microwave oven set time. What happens if I set 59 and I enter 59? This is the maximum limit possible rate. Let me increment this by 30 seconds. Let's see what happens. It gets to the 60. 60 is the maximum limit because 60 is the maximum limit of minutes. 60 minutes are equivalent to 1 hour. So whenever I press, it is 46 seconds. 46 plus 30 is 73. It exceeds. Yeah, but the limit is 60. 60 minutes is the limit. So it will reset to limit whenever the timer is overflowed. Yeah. So let us stop with this. This project is a simple project, but it requires in-depth understanding of how each one of the peripherals work, and also how the microprocessor gives commands and gives controls to various functions, how it retrieves back the control within the functions, and how a timer works, how an interrupt service request works. All these things, they have been handled nicely by our mentor. So let me conclude this by saying this microprocessor and embedded system project and internships by EMERTXE, it is really helpful for us in meeting the industry standards and as well as provided us exposure as promised to versatile applications of embedded systems. We had a really good and strong foundation in the basics of embedded systems with the help of these projects, and also we know the current trends of the market and how the embedded system is going and how it will be in the future and what is the scope of the embedded systems. All this thanks to the DISHA workshop, and also we have a resume building workshop. They have taught us how to build a resume so to attract and present ourselves in the best way possible. So I thank EMERTXE for their internship. There it is really helpful and it is extreme in many ways, just like their brand name. It is really extremely helpful, extremely useful, extremely on the point. What they promised. They promised us a industry ready self, and they achieved it. Thank you, MX.